Hi all, welcome to LearnCodeRepeat. So today we'll be looking at day 18th of the October LeetCode challenge. So let's look into the problem. So the problem is best time to buy and sell stock for. You are given an integer array prices where prices of I is the prices of a given stock on ith day. Design an algorithm to find the maximum profit. You may complete at most k transactions. Notice that you may not engage in multiple transactions simultaneously, that is, you must sell the stock before you buy again. So here the example that has been provided is k equal to 2 and price is 241. So I can buy the stock on first day at price 2 and I can sell the stock on second day at price 4. So the profit will be 4 minus 2, which is 2. Similarly here in example 2, I can buy the stock on second day price 2 and I can sell it on third day. So I will get the profit as 4 here. Then again I can buy the stock on fifth day and sell it on sixth day. So here the profit will be 3. So in total the profit is 7. So if you see here, once we buy the stock, we can have two options here. One is either to sell on the next day or we can skip it, right? We can skip to sell. Now if I am skipping this, I can again have two options on the next day. I can again skip it or I can sell it. But if I sell it on second day, then the next day I can either buy it or again I can skip it. Okay, so these are the options that we have, right? We can either buy, skip or sell. So these are the three options that we can have, right? So every day, right, we can check what is the max profit that we can get. So what is the profit? Profit is nothing but my previous buy value or previous max till that point. So max till the point plus my sell value. Okay, this is my profit. Now how to get the max till that point, right? So for the max till that point, I can decide whether to skip the buy option or to buy, whether to skip the buy option or to buy for that current day if it was not bought earlier, right? That is the max till that point. And similarly for selling, I can either skip it if it was sold earlier, or if it was bought earlier, then I can sell it, right? So here it was bought earlier, so I can sell it, or if it was sold earlier, then I can skip it. So here it was sold earlier, so I will skip it, right? And also it has been provided that there will be only k transactions. So one transaction is equals to 1 buy plus 1 sell. Okay, so this is one transaction. So if there are n days, right, if there are n days with the prices listing that we have, so in total there can be only n by 2 max transaction, right? So if I have been given k as the value of transactions that we can have, so we can have at most 2k transaction for n day, right? So if my 2k is greater than n, that means it's as good as saying that you can ignore the number of transactions. You have infinite number of transactions that you can have for that given list of prices, correct? So this is an important factor that we can use to optimize our algorithm. So let's look into the algorithm. So here the first thing that we have to check is if the prices length is less than or equal to 1, then we can directly return 0. The second point, that as I mentioned earlier, if 2 times k is greater than or equal to prices dot length, then we can very well assume that it's a infinite number of transactions that we can have. So in that case, my max profit will be, I can simply check if my current price is greater than my previous price, then do a current price minus previous price and add that to the profit. So it's a very simple calculation that we can have here, and we can add that to my profit, and I can just sum that up. So this is a simple optimization to the algorithm. Now once I have done with that, if my twice the number of transaction, it is less than my price length, in that case what I need to do is I need to check for the given prices, I will check for each number of transaction. So here as I said earlier, for a given buy I can either skip the buy option, that means I can keep the buy as is, or I can do the buy operation. So if I am doing the buy operation, whatever is my previous profit, so my previous profit is the my previous selling point here minus my current price, so that will be my new buy. So buy of I is nothing but I am selecting the best price which I can buy till that point, and sell of I is I am checking the best price till that point where I can sell it with profit. So it is either I can keep the profit as is or I can sell at that point. So my current price is the price and I can sell at that point. So if I am selling at my current price, so whatever price I sell, that will be the profit plus my previous buy value, right. So that profit will get added to my previous buy value. So here I am doing buy of I plus price, and at the end sell of k will have the final profit. Okay. So this is the simple algorithm for this particular approach. This is the bottom up approach of dynamic programming. You can also do it in top down approach where you can recursively call with memoization, and you can use the same approach for that. So let's run this code. And the code is accepted. So the runtime complexity of this algorithm will be n into k, where n is the number of prices or the price length and k is the number of transactions. So that's it for this video. Thank you.